Well, good afternoon, good morning, everybody. I'm Natalie Van Doorn. I'm a research urban ecologist working for the Forest Service in California in Pacific Southwest Research Station. I'm stationed up here in San Francisco Bay Area. So my research very broadly looks at how and why urban forests change through time and what can be done to make them more resilient. And my current project right now is co-leading a project with Dr. Laura Roman on trees in schoolyards. And somebody, I think, will post a link in the chat. This is with support from CAL FIRE and Forest Service Region 5 State and Private Forestry, and in partnership with Green Schoolyards of America. And we're going to be looking at trees as a resource in schools, their cooling benefits, and what sort of management is being done and can be done for the trees in these select elementary schools across California. But today I'm going to set the stage talking about stressors and opportunities in urban forests in the West. And then I'll pass it off, then I'll pass it off to Matt Ritter. So urban trees are considered to be a relatively cost-effective nature-based solution for mitigating climate change and making our cities more livable. Of course, by now we probably all know the different benefits that are produced by these trees, such as air and water, air pollution removal, carbon sequestration, heat mitigation, and also just improving human well-being. However, urban trees themselves are also very vulnerable to climate change and the stressors such as drought and urban heat. For example, cities in California right now are facing more extreme climatic events. So in general, in California, we're seeing that in the next 75 years, we're going to have higher temperatures. Precipitation will be more varied, but in general, more precipitation during each of these storm events, and also stronger winds. And maybe more importantly, these mega droughts. And so we've already seen a couple of mega droughts. The last one, we had a very severe, unprecedented drought in the whole 1,200 plus year record that happened in 2012 and 2015. And one of the unfortunate responses or non-response of communities was that people stopped watering their trees. And so this is really unfortunate when there are mature trees that are the ones that are giving off these ecosystem services. When they stop being watered, many of them died, and it's those trees that are producing the ecosystem services, and they take so long to grow that it's really a missed opportunity to not continue watering the trees. And so we have this conflict in the West of climate change, irrigation, and all the additional stressors. In addition, we have the pests and pathogens. So this is, of course, nationwide. There are different pests and pathogens, some invasive. In California, in Southern California primarily, we've had the invasive shot-hole borer, which is a pest pathogen complex. It's killed many, many trees in Southern California. The difficulty is that there are a lot of species that are the host for this pest pathogen complex. Something like 33%, I think, of the species in the regions that we looked at in Southern California were susceptible to this pathogen. And now it's made its way over into Northern California. Another example, this one from Hawaii, is the rapid Oia death. It's a fungal disease that's rapidly killing the forests of Oia, which are this native endemic species within the Hawaiian Islands. And of course, we can't talk about the West without mentioning fire. Previously, these used to be strictly wildfires. Then they started moving into the wildland-urban interface. And now we even have instances of fires in very urban areas. So for example, the Coffee Park in Santa Rosa, in Hawaii, of course, most recently in Lahaina on Maui. We had one of I think the deadliest fire in the US in the last 100 years. And then just to kind of put all these together, often it's these stressors that are working together that result in die-offs. So we have when it's drought combined with extreme heat, invasive pathogens. Sometimes we can have these either species specific or maybe more across the board die-offs. And we saw one recently, a couple years ago, within the city boundaries in the city of Oakland, we had this acacia die-off, which was attributed to this kind of just combination of stressors. Additional challenges are the lack of municipal funding. So during the latest recession, we had many funding cuts. Sometimes entire urban forestry departments were cut. This resulted in understaffing, which continues to this day. And often cities are just in emergency management mode. So working through the backlog of tree removals and just really not having time to plan ahead or take a breather. And sometimes it's also, if a unit is understaffed, maybe there's just a lack of networking to kind of bounce ideas off of other people, talking about different field observations, what species are doing well, and maybe finding those resources is difficult. We're also facing a lot of aging populations, so aging tree populations in cities that are more, of course, more vulnerable to the stressors that I've described. And then ultimately, a lack of money for maintenance. So there was a study that was done that looked at tree planting initiatives across the US, and they found that really most of the money goes towards tree planting and tree purchasing. Very little money goes towards actual maintenance, even in the first couple of years. For example, the watering and just the technical maintenance. So in California, right now, we as of a couple of years ago, we have about 15% urban canopy cover. It's not very high, but it's also not unusual for an area that's not originally forested. But our state has an aim of increasing the canopy cover by 10% by 2035. And so really one of the main goals is that there's no net loss of canopy. Of course, a lot of the focus has been on public trees, but I'll just point out that most of the urban forest is on private lands. And so there's always this question of how do we influence what happens on residential land? California is fortunate in that it has specific funding streams for urban community forestry. This is partly in thanks to the research that's been done at the Forest Service in the late 1990s. There was a lot of research on the benefits of trees, specifically atmospheric carbon reduction by urban trees. This was led by Greg McPherson and team, and they came out with these great guides, community guides, for all 16 climate zones in the US, which identified and described the different benefits from trees, but also the costs associated with planting and caring for trees. And I think that really helped with advocating for local funding for trees, but also helped with this sort of state level funding stream. So California is actually the only state that uses trees as a carbon sequestration device. It was formalized in 2006 by this Global Warming Solutions Act. And that act has a cap and trade provision, which feeds money into a greenhouse gas reduction fund. And then that money is taken by agencies to make California climate investments. So these have been supporting for many years now this new generation of urban greening projects. And just as an example, a couple of years ago in 2023, the entire funding stream from CAL FIRE was for greening schoolyards. and it was a big chunk of change, 121 million. Now, of course, we also have funding from the Inflation Reduction Act. And actually, one of the recipients is Matt Ritter, who will be speaking next, and he can probably mention that project. So how can we increase canopy cover? So I'll just mention that as a tree demographer, I think about sort of three different levers that we can pull. Processes that could cause an increase in canopy cover. So one is to maintain the growth of survivors. As I mentioned, it's these larger, as the tree grows, there are increasing ecosystem services that are coming off of it. Next, we can limit mortality or removals. And then finally, increase planting. And I'll also add that not only replacing trees that have been removed, but also creating additional space for trees. So it's this combination, and it depends on how hard you pull on each of those levers that results in either an increasing canopy, decreasing, or a stagnant kind of canopy cover. Another way to think about it is that we're managing for risk, and our goal is to minimize the risk of tree loss. And so some of the strategies that we can think about is to increase diversity. So on the one hand, we can phase out poorly adapted species. So, for example, stop planting redwoods in the inner parts of California. Another strategy is to expand the tree palette for what we're planning to plant, to expand it to climate-ready species. And Matt will talk more about this. In general, though, we know that high species diversity lowers the risk of tree mortality and urban canopy loss from threats, all these stressors that I've been talking about, so storms and pests and climate change in general. And we can make informed decisions about species selection, and that will help mitigate for climate change and the other stressors. And so with that, I will pass it off to Matt.